The Gobi Desert's harsh and lifeless conditions make it the ideal location for a variety of experiments, but primarily for greening it up. So much has been planted there and so much sand has been turned into an oasis. In other words, China is actively combating desertification and conducting extremely beneficial experiments. But that's not at the end of what the Chinese are doing in the Gobi. Check out this other location in the desert. It's just ordinary sand with a little bit of sparse vegetation. The greening efforts haven't reached this area yet, but eventually a complex like this appeared. At first glance, it appears to be nothing special, but if you look underneath, you'll see that the Chinese have dug a 919-foot tunnel. What is the massive project China has come up with this time? Let's figure it out. China's nuclear power industry began to develop back in the last century, and by 2002, the country already had 5 nuclear power plants and 7 reactors with a total capacity of 4. This is the beginning of what will eventually be a base with over 8 miles of underground tunnels. What happened next was that China started to develop at an amazing rate and nuclear energy wasn't left behind. By 2005, reactors whose foundations were laid back in the 1990s came online, increasing China's total nuclear capacity to 15 gigawatts. 9 years later, China had 19 gigawatts of nuclear capacity, which may seem like only a 4 gigawatt increase. Although the gigawatt increase was not very noteworthy, the nation began to accelerate its nuclear development from that point on, and year after year, the total capacity continued to rise, eventually reaching 53. 2 gigawatts in 2023, or less than 9 years, virtually tripled, according to analysts, taking the U.S. primary rival, China, roughly 40 years. In the early 2020s, China announced plans to build a massive 150 new reactors over the next 15 years, with the goal of reaching a total capacity of 200 gigawatt by 2035. This ambitious goal will require investments ranging from $370 billion to $440 billion. But honestly, with all its mega projects, do you think that's where the country stopped? No, not at all. The real climax will occur in 2050 when China aims to ensure that 15% of its electricity production comes from nuclear power. If they meet that 2035 target, all that power could light up more than a dozen cities the size of Beijing. Clearly, a nuclear power plant is a more efficient way of generating energy than alternatives like solar panels and wind turbines, which are far more advanced in China. But there's more to it than that. It's obvious that China recognizes the harm that the entire network of filthy coal-fired power plants causes to its nation, and has recently been actively working to replace that method of power generation with nuclear power, which the nation intends to reach 200 gigawatts of. In addition to providing electricity to numerous cities by 2035, there may be a reduction of 1.5 billion tons of carbon emissions annually, which incidentally exceeds the total emissions of the UK, Spain, France, and Germany. These startling figures demonstrate the extent of the pollution that China is releasing into the atmosphere. China's overall push for nuclear development is further highlighted by their 60-year plan, which calls for the construction of new reactors and plants to replace 2,990 coal-fired power plants. Unfortunately, nuclear power plants produce waste just like any other energy source, and this is where China faces some difficulties. Rags, clothing, metal reactor parts, filters, and pretty much anything else that comes into contact with nuclear reactors are examples of low and intermediate level waste produced by power. In Chinese nuclear energy, these two categories account for 99% of all waste, and they are disposed of by packing them into special containers and burying them up to 330 feet below the surface. The third category, the remaining 1% of high-level radioactive waste, or HLDE for short, is a completely different matter. It mostly consists of spent nuclear fuel, but the catch is that it is extremely radioactive and stays that way. The Chinese are handling this fairly well. They have a number of specialized facilities where low and intermediate level waste is stored and processed. In international practice, the standard method for handling HLW is to bury it in stable geological formations 1640 to 3280 feet below ground to keep it isolated for over 10,000 years. This is a much more complicated process than dealing with other waste types, but for tens or even hundreds of thousands of years, it's essentially the same approach as with less dangerous waste. Just bury it. Something needs to be done about it, and no, the Chinese didn't just start paying attention to this when they suddenly had a number of reactors anticipating the issue. Instead, they began searching the country for a suitable location back in the 1980s, but it soon became evident that Inner Mongolia was the best option because they had been drilling there since the 90s. There were about 100 deep wells there, which took a tremendous amount of time, money, and effort. Just think of the cores that were taken out of those wells, which totaled an astounding 37 miles in length. The Gobi Desert was also included in the research, and the findings demonstrated that this desolate area isn't just a test site for massive Chinese greening projects, it's also a place that the Chinese laid the first stone near the sea of Zhuquan in Gansu province in 2021, and this is what the area looked like. As we mentioned earlier, dealing with high-level radioactive waste requires a lot of digging or drilling, so every Chinese worker knew that another big job was coming up, and sure enough, that same. The tunnel boring machine Bashan 1, which is 330 feet long and 23 feet in diameter, arrived at the site this year. It is the first machine in the world made specifically for drilling tunnels at a steep angle in hard rock, and it began drilling the laboratory's underground ramp. This is where the construction of the $300. This is just the beginning of a real megastructure called Bashan. The machine has already reached a depth of 918 feet. Does this mean they can now begin dumping high levels of radioactive waste underground and live happily ever after, further developing the nuclear energy sector? No, this is just the beginning. This is what the plan calls for the structure to look like. Since there will be 3 vertical tunnels, the tunnel boring machine still has a lot of work to do. In total, the Chinese have planned to construct an underground complex with a structural volume of 18 million cubic feet, which includes 8 miles of tunnels. This is reportedly the largest underground facility of its kind. The tunnel that is currently constructed is only the entrance, actually one of the entrances. Kind in the world, all in the Chinese manner. As you can see, China has no intention of limiting itself to only underground work. There will be a lot of above-ground work as well. The surface structures will span 610 acres and include a variety of administrative buildings, as well as everything else required to maintain the underground facility. The base's partially above-ground portion is. Several buildings have already been constructed, some research is being conducted there, and some workers are residing there, but there's still a long way to go before the project's construction is finished. According to the project managers, the ground and underground base will be finished in 2038. We'll take the shape that was displayed using computer graphics, and now comes the question of why. If all that is actually required to deal with radioactive waste is to bury it deep enough, this underground structure could theoretically do it. This is because the facility's location was picked for a reason, and the researchers who worked to find it. A solid granite mass covering an area roughly equal to half of Beijing was found to be a suitable location for the storage of high-level radioactive waste. The search team's head said he had never seen such a solid rock formation, and the more solid the structure and the fewer the cracks, the better it serves as a natural barrier for highly radioactive waste. Following that, Chinese and Beijing reportedly provides the best overall conditions in the world for containing the harmful effects of particularly dangerous waste from China's nuclear sector, according to foreign experts who visited the site and validated the head of the search team's conclusions. Despite this, the Chinese have not planned to dump the waste until the entire underground above-ground project is completed in 2028. High radioactive waste there, after which studies will be conducted to determine whether the site is actually suitable for storage. These studies are expected to last until 2050 if all preliminary calculations are found to be accurate, and construction of the underground storage will begin next to. The lab in 2050 will house all of China's most hazardous nuclear waste, but don't assume it will be a waste of time and money. If the location is ultimately determined to be unsuitable for storing highly radioactive waste, the building will grow into the biggest underground laboratory with the most functions in the field of highly radioactive waste disposal, and simply put, it's a very helpful facility for many countries. It's a sort of experimental field. China has already collaborated with the International Atomic Energy Agency and exchanged a lot of information with over 10 countries and regions. In addition, more than 100 international experts have visited Bashan for research, and in 2024, Bashan hosted an IAEA. 45 experts and national representatives from 17 member states, including France, Sweden, and South Korea, participated in a video conference for a training course on underground research facility and geological disposal repository design and construction technology organized by the corresponding Chinese institute. In general, you get the idea, even though the Chinese must find a new location to store the HLW. Thanks to the research at Bashan, they'll probably do it faster, also the whole world will benefit. The search group's head, who is currently working in Bashan, states that the underground laboratory belongs to both China and the entire world, which implies that many other nations will also learn. Concerning HLW storage, and if you think the Chinese will stop there, well, no. If you read this headline, you might believe that some genuinely amazing things are taking place in China. The entire set of equipment you see on your screen is what they refer to as an artificial sun. If we're using technical terms, it's the experimental advanced superconducting transformer, or simply put, these are systems that contain gas that has been transformed into plasma at temperatures above 150 million degrees Fahrenheit. They are held in place by magnetic fields, but why go to the trouble of conducting controlled nuclear fusion? This process, which is essentially the controlled merging of atomic nuclei, has significant advantages over nuclear fission, which is the conventional method of producing power in nuclear plants. Nuclear fusion releases 4 times as much energy as the nuclear fission reaction, which is currently the standard for humanity. Nuclear fission uses uranium, and some estimates indicate that we will only have enough of it for the next 150 years. In nuclear fusion, deuterium and tritium are used. The former is essentially limitless on Earth, while the latter is artificially produced, and we can produce a lot of it as well. As for the problem of radioactive waste, which is a major concern globally and particularly in China, nuclear fusion produces a lot less of it, and it doesn't last nearly as long as regular fission reactions. In other words, developing nuclear fusion is the way that humanity is going, and China has already made some significant progress. In 2016, the artificial sun became the first machine in the world to maintain plasma at 90 million degrees Fahrenheit for more than a minute. In 2018, it reached the milestone of approximately 180 million degrees Fahrenheit. In 2023, East made history once more by producing a steady plasma wave that lasted 403 seconds. The most recent accomplishment occurred in 2025, when East broke its own record for maintaining plasma for 166 seconds. Is a significant advancement for China and the world, but Chinese scientists are not celebrating just yet because they know that much more work needs to be done, including the construction of special reinforced walls made of materials that aren't usually found on Earth. This can take a long time, but the Chinese aren't overly concerned about that either, as the China National Nuclear Corporation, or CNNC, states that China intends to construct the first industrial fusion reactor prototype by 2035 and then make this state-of-the-art technology available for widespread commercial use by 2050. However, that is only a plan for the time being, and there is already some advanced nuclear technology available. China was the first to commercialize ground-based small modular reactors for power. Conventional nuclear reactors are very large systems, and their setup can be difficult and time-consuming. For example, according to the IAEA, the average time to build a nuclear reactor as of 2022 from the beginning of concrete pouring to grid connection was 247, 20 or 7 months. Although the average construction time fell 6 years following those estimates, Borehole 3 opened in Georgia, USA in 2023 after taking 121 months to build, and Borehole 4 was finished in 2024 after taking 125 months. If you need to power a specific area in a very short amount of time, it's still a difficult procedure. Say hello to Linglong, which is currently undergoing launch in Changjiang County, Hainan Province. Conventional nuclear reactors and the infrastructure they require simply won't cut it in the short term, and those reactors take up a lot of space, making it difficult or impossible to set them up in areas with difficult terrain. It does not have all of the disadvantages of its conventional counterparts. The main module of this Chinese-developed reactor, also called the ACP-100, combines the main pumps, steam generator, and high-pressure reactor vessel, removing the need for a primary pipeline and drastically reducing the time needed to build the reactor. Other modular components, like the steel and concrete containment structures, can also be installed quickly. For instance, it took 1 hour and 48 minutes to lift and install the 550-ton outer shell, even though 6,000 workers were present. However, we should emphasize that Linglong 1 is an innovation and that the entire process is a test of how everything could work. The remaining construction didn't take. Although the reactor hasn't been fully commissioned yet, the anticipated year for this eagerly anticipated event is 2026, meaning that it will only take 5 years overall. Long either way, the first tons of concrete for Linglong were poured in July 2021, equipment installation started in December 2022, and the main internal reactor building structure was finished in March 2023. Clear, and it's important to remember that this is a test project, so theoretically the Chinese could construct comparable Linglong 1 units even more quickly once they figure it out. However, the Chinese modular reactor won't be able to match its counterparts in terms of power. Linglong 1 can generate 1 billion Watt-hours of electricity annually, which can meet the needs of decreases CO2 emissions by 808,000 tons or 7 times and benefits 526,000 households. Although the US Borehole 3 and 4 units, which have 5 million trees, produce 3,400 megawatts, which is obviously much more, the relatively low power of the Chinese reactors is offset by the fact that, in theory, scaling up is simple, and one Linglong reactor could swiftly transform into a station with numerous additional reactors similar to it. We'll just need to wait until China has at least one modular nuclear reactor in each region. All of its waste will be appropriately managed, and it will eventually be upgraded to a fusion reactor. Impossible, but you are aware of the Chinese people are capable of anything.